Hello, I am Parvez from 3rd CCC. I am going to say about Bellman-Ford algorithm. Bellman-Ford algorithm is a single source shortest path algorithm. This algorithm is used to find the shortest distance from the single vertex to all the other vertices of a weighted graph. There are various other algorithms used to find the shortest path like Dijkstra's algorithm, etc. If the weighted graph contains the negative weight value, then the Dijkstra's algorithm does not confirm whether it produces the correct answer or not. Bellman-Ford algorithm uses dynamic programming, whereas Dijkstra's algorithm uses greedy method. So what is the difference between Dijkstra's and Bellman-Ford? First one, negative edge weight. The Bellman-Ford algorithm works for a negative edge weight, whereas Dijkstra's algorithm doesn't work for a negative edge weight. Distributed implementation. The Bellman-Ford algorithm can be easily implemented in distributed way, whereas Dijkstra's cannot be implemented in a distributed way. Time complexity. The Bellman-Ford algorithm is higher than Dijkstra's algorithm. Time complexity big of V into E, where V represents number of vertices and E represents number of edges in a weighted graph. So let us see an example for Bellman-Ford algorithm. So this is the graph which contains the edges between the vertices A comma B. Let's see in the alphabetical order: A comma B, A comma C, A comma D, B to E, C to E, D to C, D to F, E to F, C to B. So these are the edges present in the weighted graph. So number of iterations to perform the Bellman-Ford algorithm is number of vertices minus 1, that is 6 vertices minus 1 equal to 5 iterations have to be performed on this graph. The Bellman-Ford algorithm is applied on this graph until we get 2 iterations with same values. So initially the graph has infinite values, that is the values of each vertex is considered as infinity except the source vertex. So whenever the parent has the more value than the vertex value and the cost between the distance between two vertices, then the parent value is changed and the vertex value is also changed. For example, here A to B is 0 plus 6, initial value is B is infinity. Since 6 is less than infinity, so we consider 6. And then A to C, the initial value at C is infinity. 0 plus 4 is 4. 4 is less than infinity. So we consider 4 as the value of C. And then A to D, D is having infinity as an initial value. But A to D cost is 5. 0 plus 5 is 5. Since 5 is less than infinity, so we consider 5 as the value of vertex D. So again, D to C, the value is, i.e. the vertex C has the value 4 now. D to C is 5 minus 2, 3. 3 is less than 4, so C has the value 3 now. And then C to B, cost is minus 2, that is the distance is minus 2, but B has the value 6 right now and C has the value 3 right now. 3 minus 2 is 1, so B has the value 1 right now and B's parent is C. So to move to B from A, the least cost is A to D, D to C, C to B. Similarly, we will calculate for every vertex from the source vertex A. We will calculate in this way but more iterations until we get 2 iterations as the same value. The Bellman-Ford algorithm is displayed here. So for every edge u comma v belongs, for every vertex u comma v, there belongs an edge E. We will calculate the cost between u comma v as in this relax algorithm is displayed over here. So if the weighted graph contains negative cycle, the Bellman-Ford algorithm returns false, else it will return true. So the time complexity for the initial single source algorithm is big of vertices, number of vertices. For the relax function is big of number of vertices into number of edges. So the time complexity of Bellman-Ford algorithm is big of number of vertices into number of edges. The drawbacks of Bellman-Ford algorithm. Bellman-Ford algorithm cannot calculate the least cost when there is a cycle that has negative weight edge. Thank you.